Chapter 14a, Modelling Motion in a Straight Line, Example 6. A stone is thrown upwards from the top of a cliff, 25 metres high. Velocity of the projection of the stone is 22 metres per second. Find the time taken to reach the base of the cliff. Now the textbook again uses those physics equations with uniform acceleration, because the acceleration in this case, because we're dealing only in the vertical direction, is gravity. Okay, so we only have that as our acceleration. And we're looking purely in that direction, the vertical direction. The stone is being thrown directly up and it's going directly down, no horizontal. I am assuming up is being positive. I'm going to do it a different way to the textbook. So for throwing this stone, the acceleration is negative 9.8. It's gravity. We know it's going to be acting downwards, so hence the negative. So if I want to go then, acceleration is dv dt, negative 9.8. dv equals negative 9.8 dt. Integrate both sides. V equals negative 0.98 t plus c. Straightforward integration. Now we were told the initial projection was 22 metres per second up, so that's positive. So to find c, when t equals 0, v equals 22. So we're going to have 22 equals negative 9.8, 0 plus c. Therefore c is 22. So v equals negative 9.8 t plus 22. So we get to our velocity. Now what we need is we want to know how long it's going to take to reach the bottom. So we're going to need position. So v equals dr dt equals negative 9.8 t plus 22. So dr equals negative 9.8 t plus 22 dt. Integrate both sides. My position vector will be negative 4.9 t squared plus 22 t plus c. Now, there's a choice you need to make now. On my diagram, where do I choose my origin to be? Now, I'm going to choose this to be my origin. That's my 0 point. That's my initial point, so I'm going to use it there. There is the option you could use down here as your origin. Both would give you the same answer and both are valid. So I'm going to say that r equals 0 when t equals 0, therefore c equals 0. So that does make it easy that I chose my origin to be my projection point. So r equals negative 4.9 t squared plus 22t. Now my question is, I want to find t when r equals negative 25. So I want to know my t when r is down here, negative 25, so we're in the negative direction. So I substitute that in and I go negative 25 equals negative 4.9 t squared plus 22t. Look, we know it's going to be a quadratic. 2.5 t squared, take 22t plus 25 equals 0. Solving your quadratic formula. Solve it on your calculator if this is tech active. From that, we get that t equals 5.429 or negative 0.9396. We know this one's invalid because t is bigger than or equal to 0. So this is our answer. At t equals 5.4. Now, depending on, usually 2 decimal places, 43 seconds, the stone will be at base of cliff. Okay, so that's how we do that using calculus rather than those physics equations.